Okay, today we're talking more about proportions, and it's looking at a table of values or at a graph and being able to tell if something is proportional or not. And then we also can find if it is proportional, what the constant of proportionality is. So first thing we need that definition. What is constant proportionality? That means if two ratios are in proportion, okay, the unit rate is the constant of proportionality. Okay, so the unit rate in a proportional relationship. So first you got to tell, yes, make sure they do make a proportion. Then find out what the unit rate is. That's your constant of proportionality. And as we do a couple examples here, that'll make more sense. But just remember when we say unit rate, that means it's a rate where the denominator is 1. So it's always out of 1. That's what we're going to be looking for our constant of proportionality. All right, so two ways. We can look at tables and in graphs to see if things make a proportion or not. So if you're in a table of values, okay, this table of values, you have the cost of tickets versus the number of tickets. So one ticket is $8, 2 is 16, 3 is 24, 4 is 32. So you want to know, is this proportional? Okay. Well, the way you check to see if this is proportional when you have a table of values, you take each individual rate and you reduce it to a unit rate. Okay? Each one of these will reduce to a unit rate. If they're the same, they all have to be the same. If they are, then yes, it is a proportional relationship. And then what that unit rate is would be the constant of proportionality. So if I have 8 over 1, I can't reduce that. That's just 8 or 8 over 1. That is my unit rate. 16 over 2. If I reduce that, I can reduce by 2, and I get 8 over 1, or 8 again. So that looks good. Those ones are the same. If I do 24 over 3, reduce by 3, I get 8 over 1 again, or 8. If I look at 32 over 4, reduce by 4, that's going to be 8 over 1 again, or 8. So are these proportional? Yes, this is a proportional relationship. The constant of proportionality is the unit rate. It's the 8 over 1. Okay? So the constant of proportionality is 8. Because that's what all of these reduce to. And that's it. You have a table of values. You just reduce each individual rate to a unit rate and see if they all match. If they do, it's proportional. If they don't, it's not. So this one we're talking about a total cost for number of family members attending something. Well, if it's 7 to 1, again, that can't be reduced. It's just 7. That's it. 8 to 2, that can be reduced by 2 is going to give me 4 over 1, or just 4. Those don't match. I already know this is not going to be proportional. 9 to 3, I can reduce by 3. That's 3 over 1, or just 3. 10 over 4, I can reduce by 2, which gives me 5 over 2. Or if I wrote it as a mixed number, 2.5. These are all different. So this is not a proportional relationship. So if it's not proportional, I don't have a constant of proportionality. I'm just done. Okay? Now, I can also look at graphs to tell if they're proportional or not. So these graphs are the graphs of the two tables of values that we just looked at up here. Okay, so the first one is the total cost and number of tickets. For one ticket, it was 8. For 2, 16, 3, 24, and 4, 32. If I connect these, dots, make it into a line, what I see is not only does it make a line, this line goes through the origin, goes through 0, 0. If your graph is a line through the origin, then it is proportional. This one over here, that second table of values, the cost and number of family members. Notice if we connect these, yes, it does make a line, but it does not go through the origin. That's way down here. It crosses at 6 up here. So this is not proportional. So to be a proportional relationship, it has to be a straight line through the origin. If that happens, it does make a proportion. And then to find the constant of proportionality, you can just look at on your graph, what is it at 1? Because 1, that's our unit rate. Remember, constant proportionality is the unit rate. When the bottom is 1, that's your unit rate. So in this case, it was up 8. So the constant proportionality would be 8. It's the same as what we got in the table of values, which it should be, because it's the same problem. Two different ways to look at it. Either do a table of values, see if all the unit rates reduce every rate, see if they all come out to be the same. If so, then it's proportional, and what they all came out to be is your constant proportionality. On a graph, if it's a line through the origin, it's proportional, and its value, the y value when x is 1, is your constant proportionality. If in your table they don't all come out to be the same, it's not proportional. If on your graph it does not go through the origin or it is not a line, then it's not proportional. And that's it.